Hello, my name is Yusuf Altan Akbaş, and I'm a first year undergraduate student at Bilkent University, and my Physics 102 project is about wireless energy transfer. The goal of this experiment is to explore how wireless power transmission works, specifically using a Tesla coil. So I designed this experiment to investigate the relationship between the input voltage supplied to a Tesla coil and the maximum distance at which it can wirelessly power a fluorescent light bulb. With this experiment, my goal was to explore concepts such as electromagnetic induction, electric fields, and transformers. As for the setup of the experiment, I created a Slayer exciter circuit according to schematic and connected it to the Tesla coil. The Slayer exciter circuit consists of a IRF 640 transistor, two 3.3 microfarad capacitors, and two resistors with 100 kilo ohm and 330 ohm resistances. The light bulb that was used was an 8-watt fluorescent bulb. A ruler was used to measure the maximum distance at which fluorescent lit up, and also a multimeter was used to keep track of the input voltage. The experiment was conducted by setting the input voltage to 10 volts and gradually increasing it by 5 volts until 30 volts was supplied to the circuit. For each voltage value, I observed and recorded the maximum distance at which the fluorescent bulb lit up, and I repeated this process for all the different input voltages. As for the results of the experiment, it was found that as the input voltage increased, so did the maximum distance at which the fluorescent bulb lit, indicating a positive correlation with a linear relationship. When compared with theoretical data obtained through calculations concerning Paschen's law, Method's formula, and electric field equations, the percentage error for the maximum distance at which the fluorescent lit varied between 7% to 18%, with the data for 30 volts being an outlier with 43% error. As for the second graph, the relationship between the voltage on the secondary coil against the electric field was plotted, and once again, there was a linear relationship with positive correlation. The percentage errors were similar, varying between 6% to 18%, with the data for 30 volts once again being an outlier. Throughout the experiment process, there were several errors and assumptions. First assumption was the value of the electric breakdown of the fluorescent light, which was found by Paschen's law. The second assumption was the secondary coil was an air core coil in order to implement it to Method's formula. And the final assumption was that the Tesla coil acted as an ideal transformer. Also, there could have been several systematic errors caused by the electronic devices nearby the experiment setup, and random errors could have occurred due to precision of the ruler that was used since the data values were small. Finally, the transistor heating up could have also caused random errors. So, in order to improve the accuracy of the future experiments, more precise measurement tools can be used, and more advanced equipment can be used to obtain experimental values for the voltage on the secondary coil. And that's all. Thank you for listening.